Hello, Mr. Price here, and this is the second video of the June 2006 M2 paper. This one will be on question 2, and this is a collisions question, although one kind of in disguise a little bit. Let's take a look at it. We have a small sphere of mass 0.3 kilograms, and it's dropped from rest at a height of 2 meters and above the horizontal ground. And it's going to fall vertically, hit the ground and rebound up vertically upwards and come into an instantaneous rate at the height of 1.4 meters above the ground. Okay, we're going to ignore air resistance and we want to calculate the magnitude of the impulse which the ground exerts on the sphere when it rebounds. Okay, so it might look a bit of a confusing question to start off with, but as soon as it tells us to find the impulse, we know that there's going to be some collisions involved or momentum. So I know that the impulse is its change in momentum. So let's model what's happening here. So we have a particle that falls and it hits the ground. And it's going to hit the ground at an initial velocity u. And it's going to rebound with a new velocity v. Okay, so we know in the moment before it hits the ground, it starts from a place and it falls a height of 2 meters. Okay, so it falls a height of 2 meters, and is it dropped at a speed? Okay, it's just dropped. Okay, and then afterwards it's going to travel up a distance of 1.4 meters. Okay, so actually we're looking at SUVAT here because we want to know its speed just before it hit, or just as it hits the ground, and the speed it rebounds at. And we've got enough information here to do that. Okay, so we'll look at the before situation. So it's dropped, so its initial velocity is 0. We want to find the speed it hits the ground. Now, I could probably do with some kind of different notation here, just so I don't get myself confused. So maybe if I change this v to be, what should I call this? u1 and v1. So v equals u1, which is equal to what we want to find, right? Okay, and we know the acceleration. We're going to resolve downwards, so its acceleration is 9.8 meters per second, and it has to travel a distance of 2 meters. Okay, so using v squared equals u squared plus 2ax. So it's a little bit blurry, isn't it? Okay, so u1 squared equals 0 plus 2 lots of 9.8 lots of 2. So you should find that the speed it hits the ground as 6.26 meters per second. Okay, now let's have a look at the after situation, because we want to know the speed it bounds back up at, so we can work out its change in momentum. So the after situation, it's u, its initial speed. We want to find out. It's not this one we just calculated, because some of this will be lost in the collision. Okay, so it's not this one. This is what we want to find. So u is v1. This is the velocity it comes to hit the ground. Okay, its final velocity. So once it rebounds up by 1.4 meters, it will have a speed of 0. X is 1.4 and A is 9.8 meters per second. So using exactly the same equation, v squared equals u squared plus 2ax. We've got 0 equals v1 squared plus 2 lots of 9.8 lots of 1.4. And you should find v1 to be 5.24 meters per second. Okay, so the impulse is a change in momentum. So initially it had a speed of 6.26 and its mass is 0.3 kilograms. And then we're going to see the difference between them. Now, here's where we need to be a bit careful. We want to find a difference between them, but they're in opposite directions here. So it's going to be more than we think. So we're going to subtract a negative value. Okay, because it's in a different direction. So we're going to subtract a negative value, so it's actually going to be the same as adding. 6.26 and 5.24 times 0.3. Okay, now don't be tempted to do negative. Yep, it's got to be subtracting a negative number. So in different directions. So you should get the impulse to be 3.45 Newton seconds. And that's job done for question 2.